Okay, so let's get started. So just some quick information here, which you guys should know for the exam. Underdamped is when your b squared minus 4mk is less than 0. So on the exam, if they ask you to prove that something is underdamped, this is what you need to show, or it's one of the methods to show. And your roots for the homogeneous portion will be a complex number. So you'll have alpha plus or minus b j or beta j. Okay. For critical, b squared minus 4mk is equal to 0, and your roots will be repeated. For overdamped, b squared minus 4mk will be greater than 0, and you will have two real distinct roots. So again, you can show what system you have based on this formula, essentially. So omega is equal to square root of k over m. Damping factor, you can find your amplitude by the square root of c1 squared plus c2 squared, which is equal to a e to the alpha t. Quasi frequency, beta over 2 pi. Quasi period, 2 pi over beta. So if they ask you to describe overdamped versus critical, overdamped takes longer to reach a final value, okay, than critical. Underdamped, it oscillates in the beginning, okay? That's because you have conjugate roots, complex roots. Another thing, your homogeneous portion is your transient portion of the equation. Your steady state portion is your particular portion, okay? So if they ask you to find one, you need to know which is which, and then just find that one particular one. So on this one, they ask for steady state. So you only find yp. Okay. Can I erase all this? Do you guys have? Yeah. I tried to think of everything, but obviously there's probably more. You guys good? Oh, the other thing. I'll quickly write it down here. Your h of s is equal to y of s divided by g of s. So that's the equation for transfer function. Okay. In real life, when you get to more of your engineering classes, your y of s is your output, your g of s would be your input. So how you go from your input to output? You have a transfer function. Good with that? So the first problem asks us to find h of s. And also, I am recording this, so all of this should be on the video. Okay. First one, we have y double prime plus 3y prime plus 2y equal to g of t. And they tell us that y of 0 and y prime of 0 is equal to 0. We have to find h of s, or we have to find h of t in the end. So what can we do here to find h of s to get to h of t? Laplace, right? It's in the s domain, that's what we want. So we have s squared y of s. And since the initial condition is equal to 0, we don't need to worry about the rest of this Laplace transfer. Plus 3 s y of s plus 2 y of s equal to g of s. Any questions on that? So we want h of s that's equal to y of s over g of s. So we can divide g of s to the left side and the rest of the function to the right side to get 1 over s squared plus 3s plus 2. Yes? So then we use partial fraction decomposition. So we get s plus 2 times s plus 1 in our denominator. If we break that apart, that's equal to a over s plus 2 plus b over s plus 1. And we can use what method now? Heavy side. A is equal to the limit as s approaches -2. Take out that denominator so that we are left with 1 over s plus 1. We plug in a -2 here to get a -1. So this will be -2 plus 1. Let me know if I'm going too fast or something. B is equal to limit as s approaches what? -1 of the function 1 over s plus 2. And this, we have -1 plus 2. So our b value is 1. So this is -1 over s plus 2 or s plus 1. H of t is equal to the inverse Laplace which is equal to the inverse Laplace of 1 over s plus 2 minus, or -1 over s plus 2 plus 1 over s plus 1. Okay. That is equal to negative e to the -2t plus e to the -2. So we all know how to take the inverse Laplace of each of those. Any questions so far? This one was like a lot of old stuff. Yeah, I read it. So the key to that is knowing that you need to put it y of s over d of s to solve it. Okay, let's move on to 2. They tell us that I have a mass of 1/4 kilogram attached to a spring with stiffness 8. So that would be K equal to 8 newtons per meters. The damping constant is 2 newtons per meter. It's pulled down 1 meter. So what is my y of 0? Positive or negative? Positive. Positive 1. Given an initial upward velocity of 2, so y prime of 0 is equal to what? -2. For the velocity, it's pushed upwards, so it's negative. That's meters per second. So that's meters. Determine the equation of motion. What is my f of t? about that. There's no constant force being applied to it. So the formula is my double prime plus b y prime plus k y equal to 0. Equal to f of t, which is equal to 0. So mass is 1/4 y double prime plus 2y prime plus 8y equal to 0. I multiply 4 across, make it a 1 in front of, or to get rid of the fraction in front of y double prime. To get to get y double prime plus 8y prime plus 32y equal to 0. So you could do this 2 ways. You could either just find the auxiliary equation and solve it that way, or you could do Laplace on it. Okay? So which one do you guys want to do? Let's see Laplace. I have s squared times y of s minus s times y of 0 minus y prime of 0. You guys should all be familiar with that. Plus 8 times the quantity s y of s minus y of 0 plus 32 y of s equal to 0. My y of 0 is equal to a 1. Y prime is equal to a 2. So that's also a 1 right there. So that if I group all of the terms in front of the y of s's, I get s squared plus 8s plus 32. And I bring everything else to the other side. I have a negative s on the left side, so on the right it's a positive s. I have a negative 2 on the left side, so on the right it's a plus 2. What did it? It's a minus 2. Thank you. Yeah. See, I messed up, but it's a negative 2 y prime, so that on the right, when I bring it up, it's a minus. And I also have a negative 8 on the left, so that becomes a plus 8 on the right. And then my y of s. So in solving for y of s, I have s plus 6 on the numerator divided by s squared plus 8s plus 32. Can you do anything with this? You need to be able to turn it into something that's on the table, right? So what's one method that you guys have learned? Complete the square. So my 8, I divide by a 2, square that quantity, and I get a 16. Okay? So that's what I need on the bottom here. So I can do s squared plus 8s plus 16, and then this 32, I have 16 remaining. Normally we add something and subtract something, but since I have a 32 there, it does the same computation. Plus 16 plus 16. This quantity here, I'll write it there. So y of s is equal to s plus 6 divided by s plus 4 now, quantity squared, plus 16. And we can rewrite that as 4 squared. Which is convenient because I have s plus 4 inside the parentheses. Hold on. They did some. Okay. Okay. What can we do next? Yeah. This is equal to s plus 4 divided by s plus 4 quantity squared plus 4 squared plus a 2 here over s plus 4 quantity squared plus 4 squared, right? For now, we have that. What do we want in the numerator here? A 4. So what can I multiply right here? 4, right? This is the same thing as if I had a 4 right here and a 2 outside here. If I can explain that. Yeah? So now I have a 4 in the numerator, and I move the 2 outside here. So we're still equivalent. Okay? So I multiplied this portion by 4 over 4. Now we have 2 expressions that are in the table. So y of t is equal to, for this portion, it would be e to the negative 4t cosine of 4t. For the right expression, I have 1/2 times the quantity, or e to the negative 4t sine of 4t. Did this make sense, everyone? Yes? I got some confused looks. So, can I erase some of this stuff? Yeah? Because we have part B and C. So. Part B wants us to write it in the form of y of t equal to a sine, and they show omega t plus b e alpha t, but this is, we've been treating that as beta, like I said before. So we need to put it in this form. Our a is equal to the square root of c1 squared plus c2 squared. What is c1? So I have the square root of what? What would c1 be? Just 1? Okay. It would be the 1 here. So we don't. The 1 squared plus, what would my c2 be? 1/2. quantity squared. That's equal to the square root. Oh, so this is 1 plus 1/4. So that's 5/4. So this is equal to square root of 5 divided by 2. Our a sine of phi is equal to 1. Our a cosine of phi is equal to 1/2. That's C1 is equal to a sine of phi. So what quadrant am I in? First quadrant. So I have the tangent of phi being equal to 2. Therefore, phi is equal to the inverse tangent of 2. Sine over cosine. Sine over, so 1 over 1/2. Yeah. Okay. Yeah, any questions on that? Yeah.
If it wasn't the first one.
Okay, so yeah, so you either have to subtract from pi or add pi or something like that, right? So I can go over that. Let's finish this and then I'll go over that. So that y of t is equal to our a value, square root of 5 over 2 times e. Y of t is equal to square root of 5 divided by 2. That's our my a value times e to the negative 4t times sine of 4t plus inverse tan of 2. So this is my final answer. Are you guys good with that answer? The question that was asked was, what if it's not in the first quadrant? So this is in the first quadrant. So let's erase some of this here. So say it was in the second quadrant. Okay, my angle that I would get from theta would be this angle. Okay, what I want is that angle. This angle is equal to pi. So if I'm in the second quadrant, it's pi minus inverse. I think it might be inverse tan of whatever you get there. Okay. Now, if it's in the third quadrant, so that is the angle that you get from inverse tan. Okay. We want to start from this correctly from this 0 value of pi, and this we know is pi. Okay. So then I do pi plus inverse tan. Okay. Yeah, I'm probably right. And if it is in the, I've never seen them give anything in the fourth quadrant, really, but it's the negative of it. Okay. So if it's in the fourth, so this is third, negative. Because we want everything to start from the 0 pi space. Yeah, that's a good question that people normally want to ask. And the last portion of this problem is whether the system is underdamped, correctly damped, or overdamped. Okay. How would we calculate that? B squared minus 4mk. B squared minus 4mk has to be what? Or we need to find that out first. My B value was 1 over 4. That was my mass. Minus 4 times 1 over 4 times my K value, which was 8. Oh, sorry. Yeah, sorry. Mass was my bad. Thanks, guys.
That was 1/4. Then the 1/4.
There we go. Thank you. B squared minus 4mk. So n was 1/4. B is equal to 2. K was equal to 8. So this ends up being 4 minus 8, right? And like that's -4. But all we need to know is that it's less than 0. Then since it's less than 0, the system is underdamped. Okay. So that is how you would show that you know that it's underdamped. What is the other way of showing? If you had originally found it through auxiliary equation, and you found out that your roots were complex numbers, they were complex conjugates, right? That is a sign that the system is underdamped. So then you wouldn't have needed to show B squared minus 4mk. You could have said that my roots were complex numbers, and the system is underdamped. But this is a great way to check whether you're right or wrong also. You guys good to move on? So number 3, we have an RLC circuit. My L is equal to 10 henries. R is equal to 120 ohms. C is equal to 1 over 1,000 farads. I have voltage equal to 17 sine of 2t. And the initial conditions, current at 0 is equal to 0, and charge at 0 is equal to 1 over 200, or 2,000 coulombs. However the symbol is that. So they give you all that information. They want us to find the steady state current, okay? So what part of the equation do I need to find for steady state? YP, right? And the nice thing is they do give you all the equations for current and charge. They want us to find the steady state for the current, okay? What is my current I or Q? That's something. Current is I, okay? one thing that you should know is that I is equal to the derivative of Q, right? It's charge over time, that's current. So the equation we use is L times d squared I divided by dt squared plus R di dt plus 1 over C I equal to derivative of energy with time. So we fill everything in. We get 10 I double prime plus 120 I prime plus, it's 1 over 1,000. So if I have 1 divided by 1 over 1,000, that ends up being 1,000 I equal to the derivative of 17 sine of 2c is 34 cosine of 2t. Any questions on that? We divide everything by 10 to get I double prime alone. So I double prime plus 12 I prime plus 100I equal to 34 cosine of 2t. Oh yeah, sorry, 3.4. Okay. They tell us not to use Laplace in the problem, so that we have to do the other method where we have to have a common equation with coefficients. Now, in the work that they have here, they don't do the auxiliary equation to find if you have repeated roots or not. Okay? Because you need to know whether if it's repeated in the YP, then you multiply by a T or not, right? That is something that you should always do, and I'm just telling you as a reminder. But I'm going to go ahead and go with the IP. So for example, IP is equal to, since that's a trig, a cosine of 2t plus b sine of 2t. I always recommend checking first, so that we would need to do the quadratic formula here, right? So b squared plus or minus 1 over the square root of all of that. Well, let's just why am I blanking out? It's negative b plus or minus the square root of b squared minus 4ac divided by 2a. Right? Yeah. Just by looking at it though, this I have negative b negative 120 divided by 2. So I will have some exponential term there, right? Am I losing you guys? Or if I were to write out the homogeneous equation, I'll have some exponential term multiplied to some trig term, right? So that means that I won't have a repeated IP equation, okay? So that means we can continue with just finding IP, yeah.
So when you do that, do you find the roots?
Yeah.
Do you do it before you divide by 10 or after you divide?
Do it after, once you get this. It'll be equivalent anyway, but it's always good to have a 1 there. Also, yeah, this is more simplified version of it 2. So you have smaller numbers to do this. But this is something that you should always check. Okay? Okay, back to the problem. That is my IP. I need to find I prime. We know there's a 2 there because there's a 2 there. Just want to mention that. Yeah.
So, one of the example problems I did, the particular equation was always just the quantity of multiplied by additional
T.
t.
Yeah.
And can you tell like roll the y that is in this time?
So the problem on the number 5, oh, it doesn't have repeaters. Okay. That is also if you have a critically damped. That's something that you guys need to know as well. In critically damped, you have repeated roots, right? So that when you have an equation, you need to multiply one of the terms by a t. Is that what you're talking about? Also. All right. So how about this? Do you understand why we don't multiply by a t in this?
I'm assuming it's because I have repeated roots, but
Yeah, we don't. Well, we don't have anything repeated in the homogeneous portion. I can rewrite that quickly. So we use a quadratic formula. If I were to find essentially the I of h here, right? So we would do the set this equal to 0, do the whole auxiliary equation, which would be, or this one equal to 0. So then that would be r squared plus 12r plus 100 equal to 0. Quadratic formula, negative b plus or minus square root of b squared minus 4 ac divided by 2a. Plug that in. Negative 12 plus or minus square root of 12 squared is 144 minus 4 times 1 times 100 divided by 2 times 1, right? Okay. If we solve this out, this is equal to some alpha plus or minus beta j, right? I will have an alpha value. Alpha value won't be equal to 0. Okay. And I will have some beta value, but just by looking at it, like the beta value will be different from this too. Okay. So it won't match my particular solution.
okay, so that's
Yeah.
so it's the
If they did match,
0 plus or minus whatever plus or minus.
yeah. So you can't have the same thing repeated. So if this beta did turn, if this was 0 and beta turned out to be a 2, then we would multiply all of this by a t. Okay. Yeah, so you should always check. Make sure. Is that good, guys? So in this, I just have that as my IP equation. And then I need to find I prime and I double prime. I prime comes out to be negative 2 a sine of 2t plus 2 b cosine of 2t. I double prime, derivative of this is negative 4 a cosine of 2t minus 4 b sine of Okay. That's my I double prime. So, are you guys good with this? Yeah. My I prime, I'm multiplying it by a 12. So, right here, I'm just going to make this a minus 24 and this plus 24. Okay. My I, just IP, I'm multiplying by 100. So, I'll multiply that by 100, so I have 100 up here and 100 up here. Okay? And I need to add them all together because I substituted essentially everything. So this I substituted here, this I substituted here, and IP goes there. When I add everything, I can add my cosine terms together. So I get 100 plus 24 minus a 4. Sorry. 100A minus a 4A is a 96A plus 24B, and that's multiplied to cosine of 2t. Adding the like terms. For my sines, I have minus 24 sine that's a sine, that's sine, that's a sine, minus 24a, so plus negative 24a. I have 100b minus 4b to get a 96b plus 96b, and that quantity is being multiplied to sine of 2t. Any questions so far on that? And that is equal to the force. Now I can compare like terms. So for the cosine of 2t terms, right here, I can take out a 24. So then I have 24 times the quantity 4a plus b equal to 3.4. 24 times 4 equals 96. For sine of 2t, I can also take out a 24, and I get negative a plus 4b equals 0. Any questions so far? Okay. Since this is equal to 0, I can solve for a here. A is equal to 4b. And then I can plug that back in my first equation for a to get 24 times 4 times 4, so I get 16b plus a b equal to 3.4. 17b is equal to, and if we just simplify that, negative 3.4 divided by 24 if you b is equal to 3.4 divided by 24 times 1 over 17, right? We know that 3.4 is divisible by 1.7, right? So I can actually make this a 34, and that's the same thing as having a 10 in the denominator. Essentially, I did that, okay? So this is just trying to simplify it. Because you don't have a calculator. So that is 34 divided by 240 times 17 in the denominator. This gives me a 2 in the numerator. So this is equal to 1 over 120. And that's my b value. A value is 4 times 1 over 20. So that's 4 over 1 over 20. So we can keep that. Okay. And it's because in our final solution, and you don't need to have it like this, but we can actually have 1 over 120 outside times the quantity 4 cosine of 2t plus sine of 2t. So if you didn't simplify it, you just wouldn't group them together. So this is what they have on the answer, but if I were doing it, it would be like this. I would have simplified this to get divided by 4, so 1 over 30. And then I would have written 1 over 30 cosine of 2t plus 1 over 120 sine of 2t. That's if you simplify them. So if I were actually doing it, I would have done that, but this is also valid. And this is how they have it as an answer on the sheet, but both are good. Any questions on that problem? This is a long exam. Can I erase all of this? Yeah. And we only needed to find the steady state, so we were done with finding IP. Okay. The next one, there is no external force, so it's just a homogeneous equation, but mass is equal to 1, K is equal to A, damping is equal to 4, pushed upward 2 meters, so y of 0 is equal to -2. Y prime of 0, it has a downward velocity, so that would be a positive 10. Okay. So it has a downward velocity, so that's positive, but it is placed above the equilibrium, so it's a -2. So the equation would be y double prime plus my b value, which is 4, y prime, plus 8y equal to 0. We do the auxiliary. R is equal to -4 plus or minus square root of 4 squared, which is 16, minus 4 times 1 times 8 divided by 2. And if we simplify this, -4 divided by 2 is a -2, plus or minus. Inside the square root, I have 16 minus 32, so that's -4i divided by 2, so I get plus or minus 2i. Any questions on that? So we solve for y, that's equal to e to the -2, because of the -2 there, times c1 cosine of 2t plus c2 sine of 2t. If I take the y prime of that, I get -2 e to the -2t times c1 cosine of 2t plus c2 sine of 2t plus the quantity e to the -2t times -2 c1 sine of 2t plus 2 c2 cosine of 2t. Sorry if I'm going fast. My initial condition, y of 0 is equal to -2. Sine of 0 is what? 0. Cosine of 0 is equal to 1. So that y of 0 is essentially c1, which is equal to -2. Y, are you guys good with that? Everyone's up to speed? Y prime of 0 is equal to e to the 0 goes to 1. So I have a -2 times c1 plus 0 since sine of that is 0. Going to the second portion, e to the 0 is just 1, plus sine of 0 is 0, plus 2 c2, because cosine of 0 is 1, and this is equal to a positive 10. We found that our c1 value is equal to a -2, so I have 2c2 equal to 10 plus 2 times the quantity -2. c2 is equal to a 3. So 10 minus 4 divided by 2. So that my y is equal to e to the -2 times the quantity c1 being a -2 cosine of 2t plus 3 sine of 2t. Are you guys good with this problem? So is the system underdamped, undamped, perfectly damped, or overdamped? Any guesses? Without doing the b squared minus 4mk, we know that the system is underdamped because I have a complex roots solution. Okay? So because of this, this is underdamped. That's how I know. Any questions on that? Good. Okay. They want us to find the damping constant. So A is equal to the square root of C1 squared plus C2 squared. That's equal to the square root of -2 squared is a 4, 3 squared is a 9. So that in the end is the square root of 13. My damping factor is equal to A E alpha t, which in this case is square root of 13 times e to the -2 t. -2 t. And they also want the quasi-frequency. Quasi-frequency is equal to my beta value divided by a 2 pi. So my beta value is a 2. So 2 divided by 2 pi is 1 over pi. Okay. Sorry if I rushed this problem, but that we did in the previous problem. Okay. Last page. Number 5, they tell us mass is equal to 1. External force is equal to 32 cosine of 14. Spring constant is 16. Damping V value is equal to 4. So part A, we just have to write out the equation. So that would be my double prime plus Vy prime plus Ky equal to the force. Mass is 1, so it's Y double prime plus 4 Y prime plus 16 Y equals 32 cosine of 14. And they also want us to know the initial conditions, and they tell us that the system is at equilibrium when this force is applied. Okay. If the system is at equilibrium, that means that the starting position was 0, and Y prime of 0 is also 0, because they say it's at equilibrium at rest. So I'll rewrite those here. Y of 0 and Y prime of 0 are both equal to 0. That's not always going to be the case. And they want us to find the steady state solution. What do we first have to check for the steady state? We have to check the homogeneous portion, right? Because the steady state is the YP portion, not the homogeneous portion. So we can do the auxiliary, R squared plus 4R plus 16 equal to 0. Quadratic formula, -4 plus or minus square root of 16 minus 4 times 1 times 16 divided by 2. If you solve that out, you get -2 plus or minus 2 square root of 3 I. Okay. if I find the y steady state, which is yp, the formula I would have is a cosine of 4t plus b sine of 4t. This 4 would come from my external force applied to it, and we know that it's not repeating. No repeated roots. Where's the sign-in sheet, by the way? Oh. Did you guys sign in? Can you guys pass it down? Okay. Any questions on that? Y prime of p is equal to negative 4 a sine of 4t plus 4b cosine of 4t. Y double prime of p is negative 16 a cosine of 4t minus 16b sine of 4t. So I'm just going to, are you guys good with this? I'm going to multiply a 4 to the y prime. That is, yeah. 4 to that, I get negative 16 a sine of 4t plus positive 16 b cosine of 4t. If I multiply a 16 to y p, I get 16a cosine of 4t plus 16b sine of 4t. Adding them all up, the y double prime and the y prime cancel out. So that I am left with a negative 16 a sine of 4t plus 16b cosine of 4t equal to my original force, 32 cosine of 4t. Common coefficients for the cosine portion, I have negative 16a, sorry, negative 16b, yes, cosine is b. Negative 16b equal to a 32. So b is equal to, yeah, it's plus, sorry. Thanks. B is equal to a 2. For the sine portion, I have negative 16a equal to a 0. So a is equal to a 0. So that my y steady state is just the cosine. Sorry. Did I? Where is it? A is equal to 0. B value goes right there. So I have 2 sine of 4t. Yeah, make sure you equate them correctly. Any questions so far? Am I going too fast? No. So we have to find the resonance, but we have to show, it asks us if the system is at resonance, okay? If not, find a forcing function that would put it at resonance. So first we have to find gamma r, and they tell us the equation that's equal to k divided by n minus b over 2m squared, okay? So that's equal to the square root of k 16 divided by 1 minus b squared, which is 16 divided by 2, essentially, because m is 1. This is equal to the square root of 16 minus 8, which is equal to square root of 8, which is 2 square root of 2. Okay. Is the system at resonance? You guys want to answer? You guys know? System is not at resonance because the force applied is a 4. This is not equal to the gamma that we need for resonance. So not at resonance. And the way to show, like they ask find a forcing function that would put it at resonance, then we can just say f of t can equal some force times cosine with 2 square root 2 as the gamma t. And this would put it at resonance. Put at resonance. So you need this as part of your answer too. Okay? And then the last part, we have to describe the motion of the system. Okay. Describe the motion. Sorry, we have to describe the motion from part D. That's fine. Where's the time? Okay. They say that the system will be at resonance. Oh, sorry. I skipped part D. Right? Yeah. I skipped part D. Can I erase this? Part D, we say that there's no damping. That means B is equal to 0. And would the system be at resonance? Okay? So that means then my omega r would be equal to square root of k over m minus 0. That's equal to the square root of 16, which is equal to 4, which was my gamma value. Okay? So now that they match, we know that the system is at resonance. Now, if I were to describe a system which is at resonance and has no damping, okay, that means the way it looks is that it continuously gets bigger, right? The amplitude is going to grow boundlessly as time approaches 0. So that's how we would phrase it. So amplitude grow boundlessly as, I said 0, but as time approaches infinity. So as the system goes to infinity, the amplitude is just going to grow and grow. The system will continue to oscillate like this. And that's how we would describe the motion. Okay. So you should be familiar with how to describe it for all the different systems, though. Okay. With underdamped, critical, overdamped, you should know how to describe that. And since there was no damping, it's going to grow forever. If you don't have damping, the system is undamped, it's going to grow forever. Okay. Any questions on this exam? Yes.
Back to the RLC circuit diagram, how do you know which equation to use?
Okay, yeah. So generally, they will either ask for charge or current, okay? When they ask you for current, you use the L double prime, okay? You start off with that equation. If they ask you for charge, you only have one equation to start off with, right? LQ double prime. And then you have to look at the initial conditions that you're given. If you're given I of 0 and given Q of 0, and you're working with charge, then you have to use that middle equation. Did that make sense? So generally, the starting equation, if they ask you for current, that's I, so you use Li double prime equation. If they ask you for charge, the charge equation, Q of t, the starting one would be LQ double prime. Okay? And then you have to see what equation. You may or may not need to use the middle equation, essentially. Yeah. Any questions on that? So on Monday, I'll try to find more problems to do. Yeah.
You know, if there was anything that wasn't on this test that we covered?
Yeah, I think this pretty much covered like all the stuff. Yeah. Yeah. Normally it doesn't, but I thought it did. Yeah. Thanks for coming, guys.